Hi everyone, welcome to this video, and today we're going to discuss about a new question called word search 2. So we already solved in the word search 1 problem. I will provide the link in the description. So in word search 1 we are given a grid and a word, and we need to find if the particular word is present in the grid or not. And the rules are the same. We can go in vertical and horizontal direction to form the word, and we have to return if the present or not in the word search 1 case, and the same rule applies here too. But in this case we are given a array of words or a collection of words, not a single word. That is the only difference between the word search 1 and the word search 2 problem. So definitely we can solve this using the same solution of word search 1, and we're going to do that, but we see that that will be highly inefficient in this particular case, and we need to find a optimal solution for this one, and we're going to do that. Okay, so let's see what it asks on the whiteboard. So now then, let's consider the same example that is given in our Leet problem. That is like a grid containing O, A, N in the first row, and in the second row it contains E, T, A, and E, and in third row it contains I, H, K, R, and in fourth row it contains I, F, L, and V. Okay, and the words that we need to search inside this grid are oath, P, eat, and rain. So now if we try to search these words, we can find that the words that are present, or the words we can construct using the grid, are eat and oath. So eat, we're going to start from here and we're going to end from here. We're going to find the eat word here, and we're going to find oath. When we start from here, we're going to go down from A and end here. So from the first position we can form oath, and from this position we can form eat. So the output should contain oath and eat, and other words that are there in here we cannot form it, so we have to exclude it. So in our word search 1 we always start for a single word. We used to start from the we used to run the DFS in every position. We used to go 4 directions, and we used to increase a counter for the word when we move in any direction to check if that particular character is present in this in the grid or not. And based on that we used to move or choose our direction, and we also used to track a visited set so that we don't repeat a character while forming a particular word, right? Some of the logics will stay same, but think about that. If we use the logic, we're gonna pass one word at a time, and then we're gonna check if the word is present or not. If it returns true, then we can push that word to the result array, and same thing we're gonna do for all the kind of words. If the length of 4, we're going to do it 4. So in word search our time complexity was like n cross m, then into 4 to power word length, right? And it was expensive, and here that will again increase uh, with the length of the word again, word length of the what length of our words. So what we can do is now, rather than doing one by one, we need to make sure that the time we traverse our grid, we just have to traverse once, and somehow it should check all the all the words in our words array. So to do that, only thing we have to do is that we have to put our words in a data structure that will help us to compare our characters with, and that data structure will be try. And I have covered tries in our data structure series, so I will give the link to this also in the description. Okay, now first thing first, we using tries, what you're going to do here is we're going to put all the four words in a try with a marker of the end of the word, right? For example, we put our oath in our tries with h will have end true, end of the word true, right? So now when we start from o, right, we're gonna not only check if the limits, while running the dfs on our grid, we're not going to check only the limits like left limit, right limit, and so like ij limits, and then we're going to check if the visited yet or not. That also we're going to check. Along with that, we're going to check if that particular uh, word up to that length is present in our try or not. For example, because we have oath, o will be present, and then when we add a to oath, right, o, it will become oa. Now it gonna, when it search for oa on the tries, it will find it. Then when it goes to oaa, it will not gonna find it, but when it goes to oat in the down direction, it's gonna find it in our tries, right? And then it gonna move to the another one. This will fail, this will fail, but when it moves to h, it gonna find the OATH in our try, and at that particular time our end of word, right, in our tries will become true. So then we can add this particular word to our result. Hope you're getting the idea, because it is becoming like little bit messy here. But the thing is, everything remains the same in our DFS. Only thing is that we will maintain a try, and every time we'll check if the next letter is, we are getting the next character or letter from the try while moving in any direction. And if we find the end of the word in the try, because we are marking the end of the word when while inserting the words, we find, and then that is a word, and we can easily add that word. So now then, let's implement the solution. First thing, we're gonna see how our solution using the word search one works, right? Because we have access to that, we can import that method here. Let's make it like, okay. So let me increase the font a little bit. Yeah. Now let's import. We can import it, right? Let's let each word exist, each word exist equals to require word search. So it will give us the method, and what we're going to do is we have to run the method, the word search one problem, right? And we're going to run it for every what every word in our words. So words dot for each. So let's create a result. Let result equals to in blank array. Then we're going to create for each el or word, right? Now if each word exists, word, then result dot push word, and at the end result return result, return result. It should work. Let's test it. I have used the same test cases that are given in our Leet problem. Wow, why it failed? This word dot length. Didn't I give word? Oh, I did not pass grid. Okay, sorry, I did not pass the grid here. We have to pass grid too. Now, is it like because of the order of the words? Anywho, it looks like it's returning in a different order. Let's see. Yeah, see that? So it works. It works. It was complaining because the order of the words are different. But anyway, we still can use that. But the problem is this is not going to work in our Leet code because it will become exceed the time limit and it will complain. Okay. So we can't use this solution. Let's try to my submissions. Yeah, you see that time limit exceeded. So let's see. But I don't able to find the, yeah, here. Let's copy to editor, and now I'm gonna run it. So it will run it uses the word search one a solution. So if I run the test case, it will pass. It will give the required result, both it everything. Thing is, but if I submit it, boom, it will fail with the time limit exceeded, right? So that's that. So this submission, I cannot submit this one, but it will work. But it will work. So now let's delete it and go for our next series. Okay. So in step one, create limits so that we can use in the grid, and our and declare our variables that we're going to use in our solution. Create. Okay, good. So first thing, we're gonna create our limits, like let I limit and j limit. That is our grid dot length and grid of 0 dot length. Perfect. And now we're going to create our let result, and result equals to new set, and then let our visited array that we have to maintain a set to keep track of visited while constructing every word. Same in like in word search one. Let visited equals to new set. So all of our variable declaration are done. Now we're going to create our step one, that we're going to implement a try. Step two, a try. But I will give the link to the try video I made so that the concept of how to build a try and how it is useful, everything will be clear. Anywho, now let try equals to new map. I'm not creating a class in here. I will just or we can use, because I am exporting our functions, we can just import it and use it here. But again, in that way we're not gonna practice it, right? Let's create an add method. We can create a class separately and can use it here, but let's do it in a minimal code. Right, add, or we can say try add, or add to try. Let's add to try, add to try, and we're gonna take the word, and we have to create our logic like let node equals to try, and word for I, then word dot length I plus plus, let ch equals to word of I. Let's make it c, and if node that has c not had c, then node dot head node dot set c new map, and then node equals to node dot get c. Simple. At the end, node dot set and equals to true. So yep, this will take care of our adding the words to the try. Now in step 3, add the words to the try, and in that case we're gonna do a for loop again. Let's go for each this time, words, and we're gonna have word, then add to try word. Perfect. This will take care of adding our words to the try. And step 3, we have to create our compare logic. step 4. In our compare logic, we have to traverse through the grid like in every DFS. So we need two for loops to the row and to the column and get I and J, and then we have to pass our I and J to the DFS like in every DFS. Anyway, now iterate through the grid and call DFS. Okay, so we have to create 2 for loops now. For let I and then less than I limit, and then we're going to create another for loop that is for J, and this will be less than J limit, and we have our access to I and J now. Now we need to call DFS here, right? And that will be like, let's call it process I J, and it's gonna take our try, the root node of try, and it will also take the word that is blank for now. If the string is something that the string that we are passing here, let's call it S, so that will be used to keep appending the letters to form the word, right? So that's done. Our call is done here. So now we have to, in step 5, we need to implement the DFS. So we need to create function process, and we're going to create our I, J, node, and W. Let's call it W. Now our best case, if like in all DFS there are the basic edge cases or the limit cases are the same, right? In all DFS, that is I less than 0 or J less than 0 or I greater than equal to I limit or J greater than equals to J limit. These 4 are like the common edge cases or the base cases in almost in every DFS. Now here the specific edge case for this particular problem will be we have to check if the visited has the letter already or not, right? It should not be there. If it's there, then we have to break it. So visited dot hedge your grid I and J. This is one. Then we have to see our node has the letter or not, right? So if our node has it, if our node don't have it, then we have to break it. So for that we have to write if node has grid I and J. I am doing the same mistake that I did while solving word search 1. That is that we have to check the IJ, not grid IJ. I plus star star and yeah. Okay, now we have, in this particular case, we just have to return. We have to break our loop. Now here we have to test check our try, right? Because if we have a condition that if it's not in the try, we are breaking. So if it's coming after that logic, it means the word is present in the try, right? So now we need to update our node, that is node.get w, or our grid, sorry, not w, or grid of I and j, that is the current word. Yeah, and we have to construct our word, that is nothing but word plus equals to our grid I and j, and then again we need to check here if the two thing, right? We have to update our node, we move our node to the next, then we have to construct the word, and we have to again check if the end of the word or not, just like we see that on the whiteboard, right? So if node dot get end, and then result dot add w. That's it. Now we have to add the value to the visited, right? So visited dot add our I plus star plus j, and we're gonna write the DFS here, but after the DFS we have to remove the same node from our visited list. Perfect. Now here we have to go in 4 direction. So process I plus 1 j, then our node and word, then let's copy it 4 times, make it I minus 1, sorry, minus 1, then I j plus 1, and then I j minus 1. Then we are deleting it, and that's that. At the end, because we are pushing the result here, we are adding the word whenever we get the end, it's true. By the end of this whole process, our result will be containing the words. So now we're gonna return at the end, we can return from, and it should solve our problem. Let's test it. Oh, no, 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 no. What happened? Oh, see? Always spelling mistake. node not hedge, so it's coming from here. That's why we need to use TypeScript. Anyway, now let's run it again. Boom. That's awesome. Now let's copy this and paste it in our Leet code and see if it passes or gives a time error again, right? Let's go here, paste it, run it. Boom. Why it asking for grid? Oh, okay, sorry. Because it uses the keyword called board. Let's change it to grid and run it. Both are failed. Why both are failed? Am I returning the result or not? Oh, I did not copy it. Perfect. Now we're gonna submit it and see what happens. What? Do I have this? Do we have still the old solution? No. We created tries. Come on, man. Let's add the test case and see what is the output. See, it passes here. So there is a hint in this question that everything ends with A, so we need to find something that takes care of those situations. But for now, I think we can stop this video here. This is the solution. I think this is the solution. When you do, it should be accepted. But because of this test case, I feel there might be more optimal solution than tries, and we need to find it. I will see. So thank you very much for watching, and that's how we implement the word search 2 using tries. I can say it did not pass, but we'll see if there is another solution for that later. So thank you so much for watching.